As the climate warms, it will have a number of direct and indirect impacts on the environment, the biosphere and people. As the water cycle gets more active in a warmer climate, the patterns of rain and snowfall around the world will change. In particular, heavy rain tends to get heavier. This figure shows all the regions where we have already seen extreme rainfall getting heavier. As weather patterns change, some regions of the world will get drier, particularly in the subtropics and in other places, such as the UK, although the total amount of rainfall may stay the same or increase. It will tend to come in heavier showers rather than being more equally spread through the year. Of course, there will always be extreme weather, and it can be very hard to say whether a particular extreme weather event has been made worse by climate change, or whether it would have happened anyway. The easiest type of extreme weather to attribute to climate change is extreme heat, or heat waves. There is currently low confidence in attributing any changes to the number or position of storms in the Northern Hemisphere, including the low pressure systems which affect the UK and tropical cyclones. The direct impact of global warming on the weather will lead to indirect impacts for people and nature. All life on Earth, for ecosystems to human civilizations, is vulnerable to a changing climate. This can be seen from the depths of the ocean and at the tops of the highest mountains, in rural areas as well as cities. It is causing severe and widespread disruption in nature and in society, reducing our ability to grow nutritious food or provide enough clean drinking water, thus affecting people's health and well-being and damaging livelihoods. The impacts of climate change are affecting billions of people in many different ways. The oceans warm up as the atmosphere warms. Because water expands as it gets warmer, this leads to sea level rise. In addition, as ice sheets and glaciers melt, they send additional water into the oceans, leading to even more rise. Global mean sea level rose faster in the 20th century than in any prior century over the last 3 million years, with 20 centimetres rise over the period from 1901 to 2018. Sea level rise has accelerated since the late 1960s, with an average rate of 3.7 millimetres per year over the period from 2006 to 2018. Sea levels will rise between 18 centimetres and 23 centimetres more by 2050, and between 38 centimetres and 77 centimetres by 2100. It doesn't sound a lot, but by 2100, land now home to 200 million people could sit permanently below high tide line. Because the oceans and, in particular, the ice sheets of Greenland and Antarctica are very slow to respond to changing temperatures, they will carry on melting long after we succeed in reducing greenhouse gas emissions. As the temperature of the oceans changes, it also has impacts on life in the oceans. Coral reefs can be badly damaged by warmer waters, and the changing timing of the seasons can have particularly significant impact on breeding patterns of some organisms. Carbon dioxide emissions also cause the oceans to absorb more CO2, which increases the acidity of the water. The pH of the surface seawater has decreased by 0.1 since the beginning of the industrial era. By the end of the 21st century, the additional decrease in surface ocean pH is projected to be in the range of 0.06 to 0.32. The consequences of changes in pH for marine organisms and ecosystems are just beginning to be understood. The distribution of plants and animals across the globe is changing, and the timing of key biological events such as breeding of flowers is altering. These trends are affecting food webs. In many cases, this reduces the ability of nature to provide the essential services that we depend on to survive, such as coastal protection, food supply, or climate regulation via carbon uptake and storage. Changes in temperature, rainfall, and extreme weather have also increased the frequency and spread of disease in wildlife, agriculture, and people. We see a lengthening wildfire season and increasing in the land area burnt. Roughly half of the world's population currently experiences severe water shortages at some point during the year, in particular due to climate change and extreme events such as flooding and droughts. People living in cities nowadays face higher risk of heat stress, reduced air quality because of wildfires, lack of water, food shortages and other impacts caused by climate change and its effect on supply chains, transport networks and other critical infrastructure. Globally, climate change is increasingly causing injuries, illness, malnutrition, threats to physical and mental health and well-being, and even deaths. Climate change impacts are expected to intensify with additional warming. It is also an established fact that they are interacting with multiple other societal and environmental changes. These include a growing world population, unsustainable consumption, a rapidly increasing number of people living in cities, significant inequality, continuing poverty, land degradation, biodiversity loss due to land use change, ocean pollution, overfishing and habitat destruction. All these factors and pressures can lead to conflict. This infographic from the IPCC report summarises some of the impacts and how well we understand them, from flooding and storm damage to agricultural production and infectious diseases, and the displacement of people who have to find new places to live because of flooding or droughts. Mitigation is the reduction of the flow of heat trapping greenhouse gases into the atmosphere, either by reducing sources of these gases, for example the burning of fossil fuels for electricity, heat or transport, or enhancing the sinks that accumulate and store these gases, such as the oceans, forests and soil. The goal of mitigation is to avoid significant human interference with the climate system and to stabilise greenhouse gas levels in a timeframe sufficient to allow ecosystems to adapt naturally to climate change, ensuring that food production is not threatened and to enable economic development to proceed in a sustainable manner. This definition is taken from the IPCC's report in 2014. Adaptation involves adjusting to the actual or expected future climate. The goal is to reduce our vulnerability to the harmful effects of climate change, like sea level rise, more intense extreme weather events, or food insecurity. It also encompasses making the most of any potential beneficial opportunity associated with climate change, for example, longer growing seasons or increased yields in some regions. Adaptation is the process of adjustment to actual or expected climate change and its effects. In human systems, adaptation seeks to moderate or avoid harm and increase resilience. In some natural systems, human intervention may help nature to adjust. The climate has already changed and will continue to change over the coming decades, even if we massively reduce our emissions because of the greenhouse gases we have already put into the atmosphere. As the climate changes, countries need to prepare for changing weather and the impacts of climate change on sea levels, water supplies, agriculture and health. There are feasible and effective adaptation options which can reduce risk to people and nature. The feasibility of implementing adaptation options in the near term differs across sectors and regions. Adaptation to water-related risks and impacts makes up the majority of all adaptation that's being put into place globally. Early warning systems and structural measures like levees have reduced loss of lives from flooding. Restoring wetlands and forest management can also reduce flood risk. Water storage and irrigation can reduce the risks from droughts. Another area where there are effective adaptation solutions is food production, including through cultivator improvements, agroforestry, community-based adaptation, farm and landscape diversifications, and urban agriculture. Many adaptation methods depend on inclusive decision-making with local communities and Indigenous peoples. Conservation, protection and restoration of terrestrial, freshwater, coastal and ocean ecosystems, together with targeted management to adapt to unavoidable impacts of climate change, reduces the vulnerability of biodiversity to climate change. Considering climate change impacts and risks in the design and planning of urban and rural settlements and infrastructure is critical for resilience and enhancing human well-being. All countries need to act to put in place early warning systems, flood defences and build resilient infrastructure and agriculture to avoid further loss of life, livelihoods and natural habitats. It is the most vulnerable people who will suffer most from the impacts of climate change. There are mechanisms in place for countries to assess their vulnerabilities and create national adaptation plans to prepare for medium to long-term changes. In many places, such as Israel and Tasmania, Indigenous peoples' land management techniques are being adopted because they reduce the risk of wildfires. One climate change adaptation in Kuala Lumpur, Malaysia, is the stormwater management and road tunnel, which serves as a dual purpose. It carries traffic and helps combat flash flooding. The tunnel consists of 3 levels. Normally the top 2 levels carry road traffic. However, they can be temporarily used as storm drains. At the cost of about $500 million, the tunnel is expected to prevent more than $1.5 billion in flood damage and reduce the cost of traffic congestion by more than $1 billion over the next 30 years. Stefani Gianni said adaptation is the most transformational climate adaptation action at COP27. Some climate change is now inevitable, so we need to prepare for it. But the more we do to limit climate change, the less bad the impacts will be. The argument about whether we should act to prevent or mitigate future climate change or just adapt to it is happening all the time. Economic, ethical and environmental points can be debated. Back in 2006, the Stern Review on the economics of climate change concluded that 1. A 2 to 3 degrees rise in temperature could reduce global economic output by 3%. 2. If temperature rises by 5 degrees, 10% of global output could be lost. The poorest of countries would lose more than 10% of their output. 3. In the worst case scenario, global consumption per head would fall by 20%. 4. To stabilise at manageable levels, emissions would need to stabilise in the next 20 years and fall between 1% and 3% after that. This would cost 1% of GDP. Although many of the assumptions made in the report are now out of date, the basic message remains that it is globally cheaper in the long term to mitigate climate change than it is to adapt to it. Globally, to reach net zero, there still needs to be a massive shift from fossil fuels to renewable energy sources such as wind and solar energy. Associated with that, we need to develop clever ways of storing energy, as electricity production by wind and sun doesn't always happen, especially not when you want it. This could be small-scale batteries in homes or cars, or massive hydroelectric power stations where you use spare energy to pump water up to a higher level and then release it to power turbines and generate electricity when you need it. Controversially, nuclear power does not release much greenhouse gas and so could help us reach net zero, but it does have other risks and issues associated with it. Other mitigation technologies that are being developed include routing aircraft so that they use as little fuel as possible and don't leave long-lasting contrails, developing agricultural practices that reduce greenhouse gas emissions from farming, and looking at ways of actively removing carbon dioxide from the atmosphere. You'll have probably heard of people talking about planting trees to tackle climate change. Trees have many benefits, including making our environment more pleasant to be in for wildlife and for us, and for cooling us in summer. But they also take carbon out of the atmosphere as they grow, thereby reducing the greenhouse effect. The problem is that they only do this while they're still alive and growing. If the tree is chopped down and burnt, all of the carbon dioxide goes back to the atmosphere. So from that point of view, of global warming at least, they can only be a temporary solution. However, we are already committed to a certain amount of climate change, and so our actual response will require an element of both. Adaptation can happen on a local level more effectively than mitigation, which requires national and multinational action. Huge sums of money will be required to implement the technology and infrastructure that we need to achieve emission reduction targets and to prepare for the impacts of climate change. Some of this will come from governments and public finances, but businesses, banks and insurance companies also need to invest in developing the technology that we need. It's one of the many ways in which careers and industry beyond science and engineering are playing a key role in dealing with climate change. Industrial leaders are almost as important as political leaders. The Green Climate Fund is one of the mechanisms set up by the UNFCCC. It is one way that countries are able to work together to mobilise funding to pay for low greenhouse gas emitting technologies and climate resilient development, particularly in the least economically developed countries, small island developing states and African states. As part of the 2015 Paris Agreement, rich countries pledged to mobilise $100 billion per year by 2020 to cover costs of loss and damage due to climate change, particularly to those poorer countries. Loss and damage payments are what is needed when mitigation and adaptation have failed. At COP28 in 2023, there finally seems to have been some progress with this. This all ties into the concept of climate justice. Climate justice is the idea that historical responsibility for climate change lies with the wealthy and powerful people, and yet it is disproportionately impacting the poorest and most vulnerable. It has primarily been used to frame the contrast between industrialised nations that have been burning large volumes of fossil fuels freely for centuries and the poorer regions that are most susceptible to rising temperatures and extreme weather. The countries facing the largest costs are not the largest historical or current emitters of greenhouse gases. It is also worth pointing out that many climate adaptation and mitigation policies have the potential to meet more than one of the UN's Sustainable Development Goals, or SDGs, for example by reducing poverty and hunger and leading to economic growth. Net zero means that as much greenhouse gas is being taken out of the climate system as being put into it. It doesn't mean that we can't emit any greenhouse gases at all. As some emissions will be removed by natural systems, we can enhance those too. For example, peatland restoration, or enhancing rock weathering, or develop new ones such as direct air carbon capture and storage, which captures CO2 from the atmosphere using industrialised chemical processes and stores it durably in geological storage and products. Let's address a few more misconceptions before we end this video. You will see in writing or hear people say mitigating climate change means we won't be able to do certain things, such as flying or eating meat. It is really important to avoid the can't message. Reducing climate change will mean we have to change the things we do, but not that we can't do them at all. Some of the new technologies and changes will have co-benefits for air quality, human health, biodiversity, global equality, and other things. The last misconception is that measures put in place to improve air quality mitigate climate change. Largely, this is not true. Measures such as banning petrol and diesel vehicles from city centres and controlling what fuels are burned in households for heating and cooking, such as coal fires, are primarily aimed at reducing emissions of particulates, nitrogen dioxide and sulphur dioxide, which have an impact on local air quality and respiratory illnesses, but are not themselves greenhouse gases. However, they may have co-benefits for the reduction of greenhouse gas emissions. For example, through encouraging the use of electric vehicles, which either use electricity generated from renewable sources or electricity generated more efficiently from fossil fuels in large power stations than it would be in an internal combustion engine. Other measures can lead to reduced deforestation. There are a number of sources on this topic of global climate change, and some of them are included in the text below. In the next film, we're going to take a look at the UK climate.